So in assignment number 8, or unit number 8, assignment number 5, we're going to move on. We've been simplifying radicals and multiplying radicals and dividing radicals. Today we're going to be adding and subtracting radicals. So let's go ahead and get started. Suppose we try to add these radicals together. We know that we can do something like this, 5x plus 3x, because we know that that is 8x. Or we can say 5y plus 3y, because that is 8y. So when we add radicals together, it's the same thing. We can treat the radicals as exponents. 5 radical 2 plus 3 radical 2 is the same as 8 radical 2. We can try this on our calculator. We can take 5 times the square root of 2 on our calculator and get an estimate, like a decimal. Same thing with 3 radical 2 and 8 radical 2. And we will see that if we add these two together, it's the same thing as 8 radical 2. And so another way that we can talk about why this works is if I just have the square root of 2 plus the square root of 2, a lot of people want to say that's the square root of 4. But it's not the square root of 4. We know that the square root of 4 is 2. The square root of 2 is about 1.4. And this is about 1.4. But if I add 1.4 plus 1.4, it does not equal 2. What it does equal is 2 radical 2. So radical 2 is 1.4. And if I multiply that times 2, I'm going to get the same thing as I would get if I multiplied the 1.4s together. So the bottom line here is this. We can add radicals if the radicals are alike. The radicals, the thing underneath the radical sign, must be the same. Let's see how that applies to number 2. If we're going to add these together, a common mistake would be that people would write this as 7 radical 9. But it is not 7 radical 9. The solution here, we would just have to say it's 5 radical 3 plus 2 radical 6, because we can't add those together because the radical 3 and the radical 6 are not the same. And so we would just have to leave it the way that it is. Let's take a look at another example. Here we're subtracting. We have 7 radical 3's minus 2 radical 3's. Well, that's the same thing as 7x minus 2x, which is 5x, but in this case, the x is radical 3. So the answer here is just going to be 5 radical 3. If we move on to number 4. Now, it looks like these can't be done because the square root of 50 is not the square root of 8. However, if we simplify things, so for example, I can write the square root of 50 as 25 times the square root of 2. We know that the square root of 25 is 5. That's on the outside with the 2. So 2 times 5 is 10, and I have the square root of 2 there. So 2 radical 50 simplifies to 10 radical 2. If I simplify 3 radical 8, the square root of 8 is the same thing as the square root of 4 times the square root of 2. And the square root of 4, well, that's just plain old 2. So that's a 2 on the outside. That joins the 3 that's already on the outside. 3 times 2 is 6 radical 2. And so now, if I simplify those, I have 10 radical 2 plus 6 radical 2. And now the radicals are the same. If I add them together, I'm going to get 16 radical 2's. And that's going to be my final answer. Let's take a look at number 5. Here we have variables inside the radical sign. So they work the same thing as numbers inside the radical sign. If I have 4 radical x plus 9 radical x, that's simply just 13 radical x. Number 5. Again, this one looks like you can't do it. The square root of 75x and the square root of 12x, those aren't the same thing. The number and the variable in the radical must be the same if we're going to add them together. But let's see if we can simplify these. The square root of 25, or the square root of 75 is 25 times 3. And I can take the square root of 25, that's 5 on the outside, but then on the inside I'm going to have the 3 and the x. because I can't pull any of the x's out. For the 12, I can write that as the square root of 4 times the square root of 3. And the square root of 4, we know that is 2. So this is going to be plus 2. And on the inside, we have the 3 still and the x. And then the last can't be simplified. That's just radical 3x. So now the radicals are all the same. They're all radical 3x. So now I can add them together. I've got 5 here, 2 here, that's 7, plus 1 more here. That's a total of 8 radical 3x's. So if I add those together, I can get 8 radical 3x. Let's take a look at a couple more here. So let's add these together. And again, it doesn't look like we can simplify those. We can't add those because the radicals are different. But we can simplify these. Square root of 300 is 100 times 3. Square root of 100 we know is 10. So the 2 and the 10 is going to give me a total of 20 radical 3's. Then I'm going to simplify the next term. Square root of 125, well, that is 25 times 5. Square root of 25 is 5. So that 5 is on the outside with the 3, and that's going to give me 15 radical 5's. Then if I simplify 4 radical 27, I know that 9 goes into 27. 9 times 3. Square root of 9 we know is 3. So this 3 is on the outside with the 4. That's going to be negative 4 times 3 is 12 radical 3's. So do I have any radicals that are the same? Not all of them, but I do have 2 of them that are the same. 20 radical 3 minus 12 radical 3 is 8 radical 3, and then plus the 15 radical 5. And I can't add those together because those are not the same radicals, but at least I can add the 2 terms together, and I could simplify every term. Now I want to do one more question here, and this is just a common mistake that a lot of people make. I have a radical 5 and a radical 5, 1 radical 5 and 1 radical 5. The common mistake that a lot of people will put here is they will say this is equal to radical 10. But we've never added the numbers inside the radical. It's not radical 10. This is 1 radical 5 plus 1 radical 5, which is going to give me a total of 2 radical 5's. That's it. So you don't jump too hastily at this, because radical 5's I don't ever add the numbers in the radicals. I can just add how many of those radicals I have. That's what our homework assignment is going to be about tonight. We will go over that tomorrow in class. Do your best, and we will see you then.